Johannes Diderik van der Waals, Dutch pronunciation: Johannes Diderik Fn Dr. Als listen, the 23rd of November 1837 to the 8th of March 1923, was a Dutch theoretical physicist and thermodynamicist famous for his work on an equation of state for gases and liquids. His name is primarily associated with the van der Waals equation of state that describes the behavior of gases and their condensation to the liquid phase. His name is also associated with van der Waals forces between stable molecules, with van der Waals molecules small molecular clusters bound by van der Waals forces, and with van der Waals radii sizes of molecules. As James Clerk Maxwell said about van der Waals, "There can be no doubt that the name of van der Waals will soon be among the foremost in molecular science." In his 1873 thesis, van der Waals noted the non-ideality of real gases and attributed it to the existence of intermolecular interactions. He introduced the first equation of state derived by the assumption of a finite volume occupied by the constituent molecules. Spearheaded by Ernst Mach and Wilhelm Ostwald, a strong philosophical current that denied the existence of molecules arose towards the end of the 19th century. The molecular existence was considered unproven and the molecular hypothesis unnecessary. At the time van der Waals' thesis was written 1873, the molecular structure of fluids had not been accepted by most physicists, and liquid and vapor were often considered as chemically distinct. But van der Waals' work affirmed the reality of molecules and allowed an assessment of their size and attractive strength. His new formula revolutionized the study of equations of state. By comparing his equation of state with experimental data, van der Waals was able to obtain estimates for the actual size of molecules and the strength of their mutual attraction. The effect of van der Waals' work on molecular physics in the 20th century was direct and fundamental. By introducing parameters characterizing molecular size and attraction in constructing his equation of state, van der Waals set the tone for modern molecular science. That molecular aspects such as size, shape, attraction, and multipolar interactions should form the basis for mathematical formulations of the thermodynamic and transport properties of fluids is presently considered an axiom. With the help of the van der Waals' equation of state, the critical point parameters of gases could be accurately predicted from thermodynamic measurements made at much higher temperatures. Nitrogen, oxygen, hydrogen, and helium subsequently succumbed to liquefaction. Heike Kamerlingh Onnes was significantly influenced by the pioneer work of van der Waals. In 1908, Onnes became the first to make liquid helium. This led directly to his 1911 discovery of superconductivity. Van der Waals started his career as a school teacher. He became the first physics professor of the University of Amsterdam when in 1877 the old Athenaeum was upgraded to municipal university. Van der Waals won the 1910 Nobel Prize in Physics for his work on the equation of state for gases and liquids. Biography. Early years and education. Johannes Diderik van der Waals was born on 23 November 1837 in Leiden in the Netherlands. He was the eldest of 10 children born to Jacobus van der Waals and Elisabeth van den Berg. His father was a carpenter in Leiden. As was usual for working-class children in the 19th century, he did not go to the kind of secondary school that would have given him the right to enter university. Instead he went to a school of advanced primary education, which he finished at the age of 15. He then became a teacher's apprentice in an elementary school. Between 1856 and 1861 he followed courses and gained the necessary qualifications to become a primary school teacher and head teacher. In 1862, he began to attend lectures in mathematics, physics and astronomy at the university in his city of birth, although he was not qualified to be enrolled as a regular student in part because of his lack of education in classical languages. However, the University of Leiden had a provision that enabled outside students to take up to 4 courses a year. In 1863 the Dutch government started a new kind of secondary school HBS, a school aiming at the children of the higher middle classes. Van der Waals—at that time head of an elementary school—wanted to become a HBS teacher in mathematics and physics and spent 2 years studying in his spare time for the required examinations. In 1865, he was appointed as a physics teacher at the HBS in Deventer, and in 1866, he received such a position in The Hague, which was close enough to Leiden to allow van der Waals to resume his courses at the university there. In September 1865, just before moving to Deventer, van der Waals married the 18-year-old Anna Magdalena Smit. Professorship. Van der Waals still lacked the knowledge of the classical languages that would have given him the right to enter university as a regular student and to take examinations. However, it so happened that the law regulating the university entrance was changed and dispensation from the study of classical languages could be given by the Minister of Education. Van der Waals was given this dispensation and passed the qualification exams in physics and mathematics for doctoral studies. At Leiden University, on June 14, 1873, he defended his doctoral thesis over de continuïteit van den gas en vloeistoftoestand on the continuity of the gaseous and liquid state under Peter Ricke. In the thesis, he introduced the concepts of molecular volume and molecular attraction. In September 1877, van der Waals was appointed the first professor of physics at the newly founded Municipal University of Amsterdam. Two of his notable colleagues were the physical chemist Jacobus Henricus van 't Hoff and the biologist Hugo de Vries. Until his retirement at the age of 70, van der Waals remained at the Amsterdam University. He was succeeded by his son Johannes Diderik van der Waals Jr., who also was a theoretical physicist. In 1910, at the age of 72, van der Waals was awarded the Nobel Prize in Physics. He died at the age of 85 on March 8, 1923. Scientific work. The main interest of van der Waals was in the field of thermodynamics. He was influenced by Rudolf Clausius' 1857 treatise entitled Über die Art der Bewegung, welche wir Warme nennen, on the kind of motion which we call heat. Van der Waals was later greatly influenced by the writings of James Clerk Maxwell, Ludwig Boltzmann, and Willard Gibbs. Clausius' work led him to look for an explanation of Thomas Andrews' experiments that had revealed, in 1869, the existence of critical temperatures in fluids. He managed to give a semi-quantitative description of the phenomena of condensation and critical temperatures in his 1873 thesis, entitled Over de continuïteit van den gas en vloeistoftoestand, on the continuity of the gas and liquid state. This dissertation represented a hallmark in physics and was immediately recognized as such, e.g. by James Clerk Maxwell, who reviewed it in Nature in a laudatory manner. In this thesis he derived the equation of state bearing his name. This work gave a model in which the liquid and the gas phase of a substance merge into each other in a continuous manner. It shows that the two phases are of the same nature. In deriving his equation of state, van der Waals assumed not only the existence of molecules, the existence of atoms was disputed at the time, but also that they are of finite size and attract each other. Since he was one of the first to postulate an intermolecular force, however rudimentary, such a force is now sometimes called a van der Waals force. A second great discovery was published in 1880, when he formulated the law of corresponding states. This showed that the van der Waals equation of state can be expressed as a simple function of the critical pressure, critical volume, and critical temperature. This general form is applicable to all substances. See van der Waals equation. The compound-specific constants A and B in the original equation are replaced by universal compound-independent quantities. It was this law which served as a guide during experiments which ultimately led to the liquefaction of hydrogen by James Dewar in 1898 and of helium by Heike Kamerlingh Onnes in 1908. In 1890, van der Waals published a treatise on the theory of binary solutions in the Archives Neerlandaises. By relating his equation of state with the second law of thermodynamics, in the form first proposed by Willard Gibbs, he was able to arrive at a graphical representation of his mathematical formulations in the form of a surface which he called psi surface, following Gibbs, who used the Greek letter psi for the free energy of a system with different phases in equilibrium. Mention should also be made of van der Waals' theory of capillarity, which in its basic form first appeared in 1893. In contrast to the mechanical perspective on the subject provided earlier by Pierre-Simon Laplace, van der Waals took a thermodynamic approach. This was controversial at the time, since the existence of molecules and their permanent, rapid motion were not universally accepted before Jean-Baptiste Perrin's experimental verification of Albert Einstein's theoretical explanation of Brownian motion. Personal life. He married Anna Magdalena Smit in 1865, and the couple had 3 daughters: Anne Madeline, Jacqueline E. van der Waals, Johanna Diderik, and 1 son, the physicist Johannes Diderik van der Waals Jr. Jacqueline was a poet of some note. Van der Waals' nephew Peter van der Waals was a cabinet maker and a leading figure in the Sapperton, Gloucestershire School of the Arts and Crafts movement. The wife of Johannes van der Waals died of tuberculosis at 34 years old in 1881. After becoming a widower, van der Waals never remarried and was so shaken by the death of his wife that he did not publish anything for about a decade. He died in Amsterdam on March 8, 1923, 1 year after his daughter Jacqueline had died. His grandson, Christopher D. van der Waal, is a distinguished professor of chemistry at the University of California, Irvine. Honours. Van der Waals received numerous honors and distinctions, besides winning the 1910 Nobel Prize in Physics. He was awarded an honorary doctorate of the University of Cambridge, was made honorary member of the Imperial Society of Naturalists of Moscow, the Royal Irish Academy and the American Philosophical Society, corresponding member of the Institut de France and the Royal Academy of Sciences of Berlin, associate member of the Royal Academy of Sciences of Belgium, and foreign member of the Chemical Society of London, the National Academy of Sciences of the US, and of the Academia dei Lincei of Rome. Van der Waals was a member of the Koninklijke Nederlandse Academie van Wetenschappen, Royal Netherlands Academy of Sciences, since 1875. From 1896 until 1912, he was secretary of this society. Topic: Related quotes. Topic: See also. Van der Waals equation, Van der Waals radius, Van der Waals force, Redlich-Kwong equation of state, Pung-Robinson equation of state. References. This article incorporates material from the Citizendium article, Johannes Diderik van der Waals, which is licensed under the Creative Commons Attribution Sharealike 3.0 unported license but not under the GFDL. Further reading. Kipnis, A. Yavalov, B. E., Rowlinson, J. S., Van der Waals and Molecular Science, Oxford, Clarendon Press, 1996, 313 pp. ISBN 0-19-855210-6. Sengers, Johanna Levelt, How Fluids Unmix, Discoveries by the School of Van der Waals and Kamerling Onnes, Edita, History of Science and Scholarship in the Netherlands, Edita The Publishing House of the Royal, 2002, 318 pp. Schachtman, Tom, Absolute Zero and the Conquest of Cold, Boston, Houghton Mifflin, 1999. Van Delft, Dirk, Freezing Physics, Heike Kamerling Onnes and the Quest for Cold, Edita The Publishing House of the Royal, 2008, 592 pp. Van der Waals, J. D., edited and intro. J. S. Rowlinson, On the Continuity of the Liquid and Gaseous States, New York, Dover Publications, 2004, 320 pp. External links. Scientists of the Dutch School Van der Waals, Royal Netherlands Academy of Arts and Sciences. Albert van Helden Johannes Diderik van der Waals 1837–1923 in, K. van Berkel, A. van Helden and L. Palm ed., A History of Science in the Netherlands. Survey, Themes and Reference Leiden, Brill, 1999 596–598. Johannes Diderik van der Waals – Biography at Nobelprijs.org. Museum Boerhaave. 9 Nederlandse Nobelprijswinnaars. PDF. Archived from the original PDF on June 7, 2011, 2.32 MB. HAM. Snelders, Waals Sr., Johannes Diderik van der (1837–1923) in Biographisch Woordenboek van Nederland. Biography of Johannes Diderik van der Waals (1837–1923) at the National Library of the Netherlands.